Hi there, I'm Chinmayee Lakkad, a Senior Data Cloud Architect here at Snowflake, and I'm excited to showcase the unified capabilities of our platform through a demo. This will show the seamless integration of the features that are applied, all of which are designed to work together from the outset. The core design pattern highlights the out-of-the-box integration of three key product offerings that are used. And because of the unified nature, pipeline developers such as yourself don't need to stitch together the underlying infrastructure. These components, as I mentioned, are designed to work together from the start. Now, specifically, the three key components involved are A, OpenFlow, which facilitates the absorption of data from a diverse set of sources, in this case, Slack connector, but it opens up new frontiers for centralizing the data into a scalable and flexible bronze layer. B, AISQL, which allows for efficient transformation and analysis of unstructured data, including free-form text and images, utilizing familiar SQL syntax. So if you can write SQL, you can apply AI on Snowflake. And third is dbt core-based models. And these models are built using dbt projects within Snowflake, enable modular design and orchestration of AISQL-based transformations. So my goal for you is to gain a clear understanding of this repeatable pattern through this demo, and hopefully empower you to develop AI-powered data pipelines using Snowflake data. Happy learning! This is a short demo to showcase a unified data stack on Snowflake, the 2025 edition. It leverages three primary product offerings on Snowflake, such as OpenFlow, dbt projects, and AISQL, to show how a simple yet powerful combination of this trio can help open up new frontiers of communication and information ingestion and downstream analysis. And as an example, we'll look at incident management as a typical business process that has multiple steps, but most importantly, is often used for close collaboration between different parties using tools like Slack. So in this architecture, we have used Slack connector for OpenFlow that is connected to a Slack app that you can deploy within your workspace. And this OpenFlow then OpenFlow connector acts as a conduit where these Slack messages, which include your text messages, obviously, but also any file attachments that you send with it, to land into Snowflake's landing zone, which becomes the place where dbt models can pick them up and move them up the value chain. Now, the models themselves are a key piece here because in addition to your regular SQL functions, you can very well interlace those models and the definitions with AISQL and infuse AI into this automation and real-time analytics. And towards the end, we'll use a sample Streamlit dashboard to monitor from a consumer's perspective how these messages are showing up and how they're being categorized as incidents in our example. So let's get started. Now, this is the Slack channel where I have the Slack app that I'm going to use for sending the messages out into Snowflake. And this is connected behind the scenes to the Slack connector that has already been configured in the OpenFlow runtime. So this runtime, this Slack Simple Ingest connector, on one hand is speaking to that Slack app, and on the other is connected with the Snowflake landing zone where these text and unstructured file attachments will start to land. Now, one more piece, which is, I'm going to switch my screen one more time, is the dbt projects, which then use AISQL. So in this screen, what you're looking at is the dbt project, which right now is in my local IDE, but this gets deployed to Snowflake as dbt project, the schema level object, and is then scheduled from that point on. But just to familiarize you, so this is like any other typical dbt core project that you may have worked across. Right now, it just uses two different sets of models, one to process all the incidents and messages coming in into the landing zone, and then building up on top of that using curated, called as curated zone. Okay, now the thing to note here is one of the most critical models here in this scenario is this incidence model, which amongst other SQL operations that it does to process new incoming messages is AI in different formats. For example, in this case statement here, it is actually applying text and image classification to understand the category, a potential category of the incoming message, so that the downstream processing can be built up according to the category. We're also using AI to filter any message, any new message, if it cannot be related to a category, but then it needs to be mapped to an existing ticket that may already have been created, which is open, so on and so forth. This just goes to show examples of how you can start to use AI within your models for different styles of processing, whether it is filtering or text extraction or classification or simple text generation, etc. It can very well be done with SQL. Okay, so now that we understand the different pieces of this entire architecture, let's quickly see this in action. Okay, so the first message, let's say I have a user, Jane Doe, who reports that she is unable to log in to her mobile app using her credentials. Screenshot is attached, needs more investigation. A very typical note that any incident management support person might write, and it's great that they can do it right from the tool that they are using to then get the data out into the systems that need to get the data, right? So while I send this message, I'm also going to drop in the screenshot here. Okay, perfect. There we go. Now the expectation is that this message gets, first of all, landed into Snowflake through that connector, and then we can pick it up and run it through the DBT models that we just looked at, so that we have an incident created, a proper category added to it, and then ultimately it is, it shows up in our consumption dashboard there. Okay, so let me switch my screen quickly again. Now, the connector by itself, as it points to Snowflake landing zone, it creates a lot of different tables out of the box. Tables like Slack messages here, where it captures the actual text content that you send. But there are also tables like document metadata, where as these file attachments are uploaded to stages, you can track the metadata through this. And all of this is, automatically handled for you by this connector. So I'm just going to wait a few seconds for that message to land in this first stop before I trigger my task graph that I have built up using the DBT project. There we go. Okay, so this is the exact same text message that I had sent in that Slack channel where that application, that Slack app, was listening. I've got that, and I've got my file attachment also uploaded, and it's metadata tracked. Fantastic. Now, let me switch to a different screen now. So this is that DBT project that we looked at, which has already been deployed to my Snowflake account. And what I've done is, on top of the project itself, I have created an entire DAG of tasks where I've broken down different DBT commands that are supported today into different steps. So outside the root task scheduler, you have the compilation, dbt compile step, then running with select options, the landing zone models, building up on that, build the curated zone models. And then right now this step is suspended, but if I had some dbt tests, I could also run that. So in one fell swoop, I can run my entire data engineering transformation processes through this stack. So now that I have my data, what I'm going to do is I'm going to manually trigger this right now and monitor its execution. Oops. Okay, there we go. Now, this is another fantastic feature for observability of the dbt project itself, that this entire DAG and its individual steps can be monitored real time as it is executing. But then a wealth of information can also be drilled down from this query profile, which gives you access to not only the query plan, but also the telemetry. Okay. So I'm just going to wait a few seconds here. Okay, there we go. So all our steps, all our models have been constructed. How do we verify that? So this is that Streamlit, very simple Streamlit dashboard that is keeping tabs on the curated zone models, which basically tells you what are my active incidents and last known closed incidents. Obviously, we don't have closed incidents right now. Everything that we're sending in from that Slack is expected to be open. Perfect. Okay, so what you see here is that this Slack message actually got registered as a net new incident with a title that the AI discerned from the text message and a category which the AI discerned looking at the screenshot, the file attachment, because that's how the model has been designed, that if an image is available, prefer that. Use that to classify it under a certain known category. If not, fall back on the text. So this looks pretty good as expected. And then let's just verify that the model has correctly associated the right image as well. So fantastic. This is what I uploaded on Slack, and this is what I can see here. Awesome. What happens if I drop a different message? Let's say another user, John Doe this time, reported not being able to make payments through the web application. Looks like a payment gateway error per the below screenshot. So this is just to show that, our classification does take into account the different messages and the different images that we're uploading, and does a good job of identifying the right category. Okay, perfect. Let me send this. Awesome. Now, the same steps. Let's just quickly wait for the message to land here. There we go. We have our second message here, and let's see if we have that image also uploaded. Fantastic. The Slack connector did its job, landed the data here. So let me go back and re-trigger this next run. Now, ideally in production use cases, you would have this run on a schedule, which is in tandem with how frequently that specific channel is used to exchange messages and how frequently you would want them to be registered into your Snowflake system, right? There we go. Fantastic. Now we have a second incident that has rightly so been created, a new record with a new incident ID. and with the right categories identified. And if I look at the attachment now associated, seems to be the correct one that we had. All right, one last scenario before we close this demo. For that, I'm going to need this. Let's say that user Jane Doe reported she is now able to log back into the application. Seems to have been a glitch. For now, this can be closed. Now, I'm not attaching any image here, but in this text message itself, which is unstructured data by itself, I have the incident ID. And in the model the DBT model called incidents, there is an AI function applied to extract an incident ID if that is available. If not, it'll be null. And the benefit here is that if this text message is for a known incident, then just treat it as an additional comment to that existing incident. Do not create a net new record. So that's the expectation. Let's see how it turns out. There we have it. Let me go back here. Nice. So we have that last message also here. And if I were to process this again through this graph, nice. We have this run also completed. So if I refresh my dashboard here, I should see still 2 active records, but the initial error that Jane Doe reported, which was a login error, now shows up that the latest comment is actually this. So the incident ID that had been sent in the text message was able to be extracted by the AI function related to this incident ID through the DBT models as they are built, and then incrementally add this particular attribute to that. There we go. So this is how we can stitch together different elements within the Snowflake platform to showcase a unified platform story and how simple and effective it can be without breaking any security boundaries. Thank you so much for sticking around. Hope this was helpful.